Hey y'all, I am so sorry I'm not there today. I am staying at home so I can sleep all day and hopefully get rid of this stupid cough. I wanted to go through this first problem with you, and then you can work on the other ones. Hopefully, that warm up wasn't too much of a doozy. The answers to that are on Canvas, and we can go over any of that when I am back with y'all on Monday. In the meantime, let's talk about this guy. So these are the notes, the packet um, that you should have gotten. I think across the top they say like Trig Identities notes. So what they want us to do, they've given us a couple of informations. They have told us the cosine of the angle A, and they told us that angle A is between 0 and pi over 2. I'm reading right. Where am I reading? Right here, by the way. So I know that angle A is going to be in quadrant 1. And then they've also thrown another angle at us, and they're like, hey, the sine of B is negative 4/5, and that is between negative pi over 2 and 0. So that, let's work our way around the unit circle, that is in quadrant 4. So they want us to draw a sketch of each angle, A and B, and the triangle it makes. Okay. Label the lengths of the sides of the triangle. Okay, got it. List the values for sine, cosine, and tangent of A and B. Okay. And then use the appropriate sum difference identity. So we're going to find sine of A plus B and tan of A plus B. All right, rock and roll. So let's go ahead and draw a little sketch of quadrant 1 right here. And we know this angle A is in quadrant 1. And they tell us that cosine of A is rad 5 over 5. So if this was a triangle right here, cosine is adjacent over hypotenuse. So I know the hypotenuse is 5. And I know the adjacent side to the angle, which is this side right here, that is going to be square root of 5. So how do I find the other side? How do I find this guy right here? If you are saying to me Pythagorean theorem, then yes, my friends, you are absolutely correct. So let's do that real quick. Remember, Pythagorean theorem is a squared plus b squared equals c squared. So I'm going to say rad 5 squared plus b squared equals 5 squared. That is 5 plus b squared equals 25. So b squared equals 20. So b is, let me scoot this down a little bit. Can I scoot it down? Yep. B is the square root of 20. Let's go ahead and simplify that by making a little tree. So 2 times 2. So I've got 2 groups of 2, so that comes out. So B is actually equal to 2 rad 5. If you don't remember how to do this, go talk to a neighbor and ask them how to simplify a radical. Okay, so since I know all that stuff, I can find the sine of A and the tangent of A. So sine of A is opposite over hypotenuse, so that's going to be 2 rad 5 over 5. And tangent is opposite over adjacent, so that's going to be 2 rad 5 over rad 5, which I can simplify down to just 2. Fantastic. Okay, so let's go look at angle B. What's this little guy over here? So angle B, let's make that blue. So angle B is in quadrant 4. So here's our angle B right here. We're going to say that's angle B. We're going to draw a triangle, and it gave us the sine, which is negative 4 over 5. So sine is opposite over hypotenuse. And y'all, when I'm using SOHCAHTOA, I hope you remember that. So the sine, the opposite side, is going to be 4, and the hypotenuse is going to be 5. That's going to be a negative 4 since we're in quadrant 4, and we are going down 4. And so, again, to find the extra side, we can use the Pythagorean theorem. I happen to know that this is a Pythagorean triplet, so I know that this side is 3. So let's go ahead and write down our cosine, which is going to be a positive 3 over 5, and then our tangent, which is going to be a negative 4 over 3. All right, booyah. So now we have all of those things. So they want us to find the sine of a plus b. So looking at our, I forget double lightsabers. I always forget that when I put 2 fingers down, it's double lightsabers. Okay, sorry. Y'all, when I am trying to find the sine of a plus b, which is this puppy right here, I'm going to look at my formula sheet, the blue one that I gave y'all, and write down the formula for that first. So the formula, let's see, I'm going to move this up a little bit. So the sine of a plus b is equal to the sine of a times the cosine of b plus the cosine of a times the sine of b. So all we need to do is plug in all that stuff. So the sine of a, let's go look up here. The sine of a was equal to 2 rad 5 over 5. The cosine of b, which is right over here, was equal to 3 over rad 5. 3 over rad 5. The cosine of a is back on the other side. That was equal to rad 5 over 5. And sine of b was equal to negative 4 over 5. So y'all, let's just do some multiplication. So I'm going to multiply. Remember, for multiplying fractions, we should multiply straight across. So 2 rad 5 times 3 is going to be 6 rad 5. And then 5 times 5 is going to be 25. And then on the other side, I have negative 4 times rad 5 over 25. And we're in luck. We already have common denominators, so we don't have to find common denominators. So that's going to be 6 rad 5. It's plus negative 4, so I'm just going to say minus 4 rad 5 over 25. Can we do any more simplification? Yes, we can. We can say 6 rad 5 minus 4 rad 5. That's equal to 2 rad 5s hanging out over 25. Sweet. So that's going to be the sine. So now they also wanted us to find the tangent of a plus b. So again, let me use a different color. How about red? So again, I'm going to go look at my formula sheet and go ahead and write. Let me zoom in a little bit to make it easier. So this is the marker's thinner. Okay. Tan a plus tangent of b over 1 minus tangent a times tangent of b. So let's do some plugging in. Let me zoom out here so I can see my tangents. So my tangent of a is 2. Easy. Tangent of b is negative 4 over 3. And I'm going to have 1 minus the tangent of a, that's 2 again, times negative 4 over 3. So let's get in here and do some simplifying. So on top, I'm going to want to find common denominators here. So, sorry. So here, I want to give us a denominator of 3. So I'm going to multiply this by 3 over 3. So let me go ahead and do that real quick. So times 3 over 3. So that's going to end up being 6 over 3 plus negative 4 over 3. And then on bottom, I'm going to have 1. Remember, we can multiply straight across. So 2 times negative 4 is negative 8. Oh, let's make that a negative 2. Negative 2 times negative 4 is a positive 8. And then over 3. So that's going to be plus 8 over 3. And then on the top, we're going to have 6 over 3 plus negative 4 over 3. That's going to be 2 over 3. And on bottom, if we change 1 to have denominator 3, that's going to be 3 over 3. So 3 over 3 plus 8 over 3 is just going to leave me with 11 over 3. And then I have some fraction on fraction action. So I'm going to do that. And I'm going to end up with 2 over 11 is my tangent of a plus b. Look at us go. The last thing they wanted us to do down here is to state the terminal quadrant for angles a plus b and a minus b. We can't do a minus b until we do number 2, but we can state the terminal quadrant for A plus B. Oh, double lightsabers again. I didn't mean to do that. We're going to get down here. Okay, oh God, oh dear. I'm sorry, okay, I think I fixed that, but that was scary. I moved some text around without knowing it. So in order to find the quadrant, the terminal quadrant for A plus B, we can see that the sign is positive, and then we can also see that the tangent is positive, which means if we think about, remember last time in class, we said all students take calculus. And remember what this means is that here in the first quadrant, all trigonometric ratios are positive. Here only sine is positive, here only tangent is positive, and here only cosine is positive. So in our calculations, if both sine and tangent are positive, that must mean that A plus B is in quadrant 1 because both of those are positive. So that's how we can tell. Okay. What I would like for you guys to do is try the next page before you go look at all the notes filled out on Canvas. And then there's a couple of identities down at the bottom. Try those out. Your homework today is going to be a few more identities, but go ahead and try those before looking at the filled out notes on Canvas because more practice is better. Okay, y'all, that's all I got. I will see y'all on Monday. Have a lovely weekend. If you have any questions, please feel free to shoot me an email. We will be reviewing on Monday. We do have a test on Wednesday, so make sure you're ready for that. And that's all I got. Y'all have a great weekend. Talk to you soon. Bye.